For section 5.5, we're looking at volume and surface area. So let's take a look at our shapes and our definitions for those formulas. For our first shape that we have is a box. A box is called a rectangular solid. And for the general volume formula, it is the area of the base times the height. We're adding height to the dimension of area. And so when we look at our rectangular solid, we have length times width for the bottom. So now we're going to multiply that times height to get our volume. So the volume is filling up the shape. Surface area is covering this shape. So that'd be like wrapping it in wrapping paper. And so the surface area formula for our rectangular solid is 2 times the length times the width. And if you look at that picture, the length and the width would be the bottom and the top, plus 2 times the width times the height. And again, if you look at the shape, the width and the height are the dimensions for our left side and our right side of the box. That's why there's a 2. And then 2 times the length and the height is being added. And the length and the height would be our front and our back. So that gives us all 6 faces or sides of our shape together. And we have 2 times length times width, plus 2 times width times height, plus 2 times length times height. So notice that it's all possible combinations and multiplying the 3 numbers 2 different ways. Our next shape also has a rectangular at the bottom, but notice it comes to a point, and so it's a pyramid. So we have a rectangular pyramid for our next shape, and to compensate for it to going to a point, because if we just did length times width times height, we would get the same volume as a rectangular solid with those dimensions. We have to multiply it by 1/3 or divide it by 3. And so when we have our shapes coming to a point, we're going to take 1/3 in the formula. Now for the surface area, they're telling us we don't have to worry about a formula for that. But if you look at our pyramid, we have the sides of the pyramid being rectangles, and we know how to find the area of a rectangle. It would be 1/2 times base times height, and then the bottom is our length times width for a rectangle. So if we needed to find the surface area, we would be able to do that as long as we have those dimensions given to us. Okay. Next, we're looking at a soup can shape, which is a cylinder. And so for this one, we have a circular cylinder because the bottom is a circle. And we know that the area of a circle is pi r squared. And so we're going to add our height to that for our volume equals pi r squared times height. And then the surface area that we get for that looks a little tricky. Here it is for you to copy down. The surface area equals 2 times pi r squared. The pi r squared is our area of the circle. The top and the bottom are both of those, so that's why we have a 2 there. But then the 2 pi rh, we'll look at that part of the formula a little bit later so we can see where that comes from. The next shape we have has the same circular bottom, but again, it comes to a point. So we have a circular cone now. And just like with our pyramid, we have to add that 1/3 into our volume to compensate for it coming to a point. So again, the area of the base would be pi r squared multiplied by the height. And then we have to make sure to remember the 1/3. And the circular cone surface area is another one you're not expected to know. Our last shape that we have here is a ball shape. It's called a sphere. And for the volume of a sphere, we have 4/3 times pi times r cubed, or radius cubed. That's radius times radius times radius. And then for our surface area, we have 4 times pi r squared. So those are numbers that you'll need to be able to use. And in the calculator, if you need that third power, remember you can multiply the number 3 times, or that caret button on the calculator goes for power. So you could type your radius, that button, and then your 3 to get your radius to the third power for that. On a quiz or on a test, you are not expected to have these formulas memorized. You will be given a sheet with all the formulas for your area, your volume, and your surface area for them. So when we look at all 3 of those together, our area, our perimeter, and our volume here, we have perimeter equaling 1-dimensional, area equaling 2-dimensional, and volume equaling 3-dimensional. For the units, it asks us to use inches as our example. So it would be a single unit of inches when we're going around the shape. For perimeter, or again, if it's a circle, we call that the circumference. So area, we are multiplying unit times unit. When we have like 2 inches times 3 inches, for example. And so we have square units because it's 2-dimensional shape. We have length and width. And then our volume, we're adding the height. So it would be a unit times itself 3 times, which we write as the third power or cubed. So it would be inches cubed. For an example, let's draw a square and show that the perimeter is the distance around. And I'm going to draw arrows to show that. So now if we add our area, it's going to be the distance inside the shape. And so the area is inside here. And then for our volume, let's draw a box. And then we're filling up the inside of a box. I don't want to color it too much so you lose the shape of the box. So again, 1-dimensional gives you the perimeter, 2-dimensional area, 3D is our volume. The volume of a right circular cylinder is given by the formula V equals pi r squared h. One way to think of a right circular cylinder is a lot of equal-sized circles stacked on top of each other. What is the equation of the area of the circle? And I mentioned that. We're looking at the area of the base and then times the height. And sometimes we have to change the formula when it comes to a point. The edges aren't straight up. But in general, a good starting point is looking at the base and seeing what shape it is and recalling the formula for that shape's area. And so if we have the area of our bottom, then we can multiply it by their height. So an example says, suppose a circle has a radius of 2 inches. What is the area? And that again asks us to use 3.14. So it'll be 3.14 times 2 squared, or 2 to the second power. And that will give us 12.56. And again, since it's area, we have inches squared. Now, circles are 2-dimensional shapes, which means they have width and length. A right circular cylinder has 3-dimensional. And so the additional dimension that we're adding, as we've mentioned a couple times, is the height. Use my sloppy handwriting. And so the formula for the area of the circle is multiplied by this missing measurement. So yes, we get our formula when we do that, which is volume equals pi r squared height. And so what is the volume of the circular cylinder if it has a radius of 2 inches and the height of 5 inches? Well, we already know the pi r squared. That was 12.56 inches squared. So all we have to do is add that dimension of the height, which is 5 inches. And that will give us the volume of 62.8. And we're adding that third dimension. So again, our inches now is in cubic inches. The surface area is in the formula 2 pi r squared plus 2 pi r h. A right circular cylinder can be divided into 3 pieces. The top and the bottom are circles. The tube piece can be cut down the side and flattened into a rectangle. Draw the pieces of the disassembled right circular cylinder. So again, if you think of your soup can, you have your top circle and your bottom circle. Let's make them a little bit smaller so I can draw that soup can better. So here's a better look at that. And so if you have a soup can, and we're kind of laying it on its side right now to dissect it, but think of cutting that soup label off. Many schools used to collect soup labels that you could turn in to get free things for your school. When you cut that soup label and flatten it out, you get a rectangle. And so if this got curled up around the top and the bottom, that would be our cylinder. So we can see why we have a rectangle forming here. And we know that the formula for a circle is pi r squared, and a rectangle's formula is length times width. So it says we're supposed to label those pieces here. So we have our r, our radius of our circles, and then we have our length, which if we were to turn this can upside, that would be the length, and this would be the width. And so again, our formulas were area equals pi r squared, and area equals length times width. Now, if we look at our rectangle, we can see that 2 of the side lengths are the same as the circumference of the circle. So if we were to wrap this side around, we would have the same as the circumference of the circle. That's where that comes from. So we know that the circumference of a circle, since we're already using r as our variable, is that our circumference equals 2 pi r. And the way we labeled our diagram, as you can see, that represented our length. And so what measurement represents the height of it? So again, we have it laying on its side. So the height would be where our W is. So if we rewrite our formula of circumference equals 2 pi r as our length, and our height is our width, we know that the area is those two lengths multiplied together. So we get 2 pi r h. And so that's where that second part of that surface area comes from. So we need to add those two pieces together. And again, our surface area then would be our top and bottom circles. So circle area is pi r squared. And we're adding now the rectangle, which we find by doing 2 pi r h. Notice in the first one, we're squaring the r. The second one, it's r times h. So make sure that you're careful not to just accidentally square the radius in the second part just because you did for the first part. Okay, so here's some problems for you to work through to get to those practice problems using the formulas. Notice for number 6, we have a compound shape. We have a pyramid on top of a rectangular box there. So the length and the width of your pyramid is the same as the length and the width underneath of that rectangular solid. And then you're finding the volume for both of those. The bottom two shapes, they are asking you to find surface area, so make sure you're using the right formula for that. And again, I always double check and notice that your sphere does give you the radius, because remember, if they give you the diameter, you need to divide it by 2 before you start plugging in numbers for your calculations. So go ahead and pause so you can work on these, and then check your answers from the answer key. And when you're ready, let's continue on with our story problems. Our first example is using our cylinder. A can of soup is 4 inches high and has a diameter of 2.6 inches. So first things first, I'm going to get rid of my diameter and say that my radius is 1.3. Again, I don't like the idea that I can plug in that wrong number because I've done it too many times, so I just automatically change that before I even go into what it's asking me to do. First thing is to find the surface area of the soup can. So that's a matter of pulling out our formula. So again, our surface area is 2 pi r squared and that gives us the top and the bottom, plus now we need the area of the wraparound, so the label, so to speak, and that, remember, is your circumference times your height. So 2 pi r h. So now it's a matter of plugging in those numbers. And so we have volume equals 3.14. Oh, I forgot my 2 up front, so let me add that in. 2 times 3.14 times 1.3 squared plus 2 times 3.414 times 1.3. Now this time it's not squared because this is giving us the circumference, and then we multiply it by our height, which was 4. And the directions tell us to round to the nearest hundredth or 2 decimal places when necessary. And that gives us 43.27. And again, area, even if it's surface area, is in square units, so it's inches squared. Now the volume, oh, why did I put V there? I'm sorry, I probably confused you. With that, we just need to change SA up front for surface area for part A. So for part B, now we have our volume. And remember, our volume is the area of the base times the height, so pi r squared h. So our volume will equal 3.14 times 1.3 squared times our height of 4. And so that gives us an answer of 21.23. And volume is in cubic inches. Let's move on to our next example. We have Barbara's Bombastic Bakery, and we have wedding cakes. We can see by the picture that the bottom wedding cake is a diameter of 16 and a height of 4 inches. Again, I'm going to go ahead and change that to 8-inch radius for the bottom layer. But let's go ahead and continue reading our problem now that we've taken a look at the picture a little bit to get an idea of what it's talking about. The volume of a serving of a wedding cake is equivalent to the volume of a rectangular piece of cake with measurement 1 inch by 2 inches by 4 inches. Each serving of a wedding cake costs $1.25. Okay, so what is the volume of one slice of wedding cake? So here's the slice dimensions. So volume, and it says it's a rectangle, so length times width times height. Sorry, I was going to put the answer instead of the 4 there. 1 times 2 times 4, which will give us 8 cubic inches. The bottom tier of a round wedding cake has a diameter of 16 inches, and the cake tier is 4 inches high. What is the volume of this tier of cake? Round to the nearest cubic inch, so we're rounding to the nearest whole number. We already changed our radius in our picture, so our volume is area of the base, which is a circle, so 3.14 times 8 squared. Then we have to multiply it by its height of 4 inches. And so when we round it, 1 decimal, or sorry, to the nearest whole number, we'll get 804 inches cubed for our volume. So how many equivalent slices of wedding cake are there in the bottom tier of this cake? Round to the nearest whole slices. And so we have 8 cubic inches being the size of one piece, going into 804. And we would get 101/2. That's going to round to the nearest whole number, which would be 100 slices of cake. I'll gladly eat that leftover sliver. It looks like dices, but I tried to spell slices with my cursive. So then it asks us, how much should she charge for this tier of wedding cake? And so in the story problem, it said that it costs $1.25 per serving. So we'll multiply that by 100 slices. And we get $125 is how much she should charge for that bottom tier based on the cost of $1.25 per slice. Here we have a story problem that you will see again. A glass ornament in the shape of a sphere is to be packed in a box with soft foam pellets for protection. The ornament has a diameter of 4 inches or a radius of 2. Fix that. The box is a cube whose side length is 5 inches. So first it's asking us the volume of the glass ornament. And so it is a sphere. So remember the formula for a sphere is 4/3 pi r cubed. So 4/3 times pi of 3.14 times our r radius of 2 to the 3rd power cubed. And so we get, when we multiply all of that stuff together, 33.49. And again, volumes in cubic, and then we have inches, so cubic inches. The volume of the box, since it's a cube, we didn't talk about that. A cube has all sides equal, just like our square. And so since length times width times height are all the same, we can represent that as the side to the 3rd power, because again, all 3 numbers are the same. And so with this box, it's 5 to the 3rd power. So 5 times 5 times 5, which gives us 125 cubic inches inside our box. So that's a lot of space in there for that glass ornament. So we need to know how much of the space is left to be filled up with these foam pellets. So we had 125 for our volume of our box minus the 33.49, which is how much volume the ornament takes up. So that leaves us 95.51 cubic inches of space left to fill with foam peanuts. Two more examples to go. For our next one, Jerry is a tool and die maker. He's creating a specialized solid steel cone. So since it's solid, that's volume. And it asks us how much steel will be used when we have a 12.125 centimeter tall and a radius, good, we don't have to change that number, of 4.4. So again, our volume, we have a circular bottom, so pi r squared. Since it's a cone, we have to put a 3rd in front of it because it comes to a point. And we need to make sure we multiply it by the height. So let's plug in our numbers. We have volume equals 1/3 times 3.14 times our radius of 4.4 squared times our height of 12.125. So now that we have all our numbers plugged in where they belong, we can type that in the calculator. And we see that the steel will be 245.69 cubic centimeters in volume. So for our last one, the Louvre pyramid is a rectangular pyramid made of glass and metal, which is located in the courtyard above the Louvre Palace in Paris, France. The pyramid has an approximate height of 21.6 meters, and each side of the base has a length of 35 meters. What is the volume of the Louvre pyramid? And so first, we'll have our volume equals 1/3 since it comes to a point. And we have length times width times height because it does have a triangular base. And so we will do 1/3 times the length of 35 times the width of 35, because it says each side of the base, so it actually is a square down there. So we could have used 35 to the second power instead of 2 35s, times the height of 21.6, which when we multiply all those together gives us 8,820. And that is in cubic meters. Each triangular piece that makes up the side of the pyramid has a height of approximately 27 meters. What is the surface area of each triangular piece? And so it says, notice the height of the triangular side is different measurement than the height of the pyramid, because again, when it's slanted in, it needs to be longer to be able to be on the outside versus on the inside here. So the surface area, we don't have a formula that we were given for the surface area of the pyramid, but we can see that we have a square bottom and then the triangles on the sides. So the surface area of each triangular piece would just be the area of one of the triangles. And so we know that the area is 1/2 times the base, which is 35, times the height, which is 27, and that gives us 472.5, or 472.5 square meters for each side. And so the surface area is equal to the area of the base plus the total area of the 4 triangles. And so our surface area will equal the area of the base, 35 squared. Length and width are the same. And then we have to add to it 4 of these triangles that we measured to have an area of 472.5 meters squared. And so when we multiply that and add it to the 35 squared, we get 3,115 meters squared. The 35 squared was 1225, and then the 4 times the triangles gave us 1890. If you need to check your math as far as those two numbers go to get the 3,115 meters squared. Good luck with these formulas. If you have any difficulties on your problems, let me know. Otherwise, I'll see you next time for 5.6.